So once again, you're all welcome. We're going to dissect into this whole efficiency, productivity measure, but more importantly, we want to see the returns to scale. Okay, generally, there are about 4 different returns to scale. And we're going to look at them. And it is based on the returns to scale you choose. That will determine the efficiency score you're going to have. It's based on the returns to scale you choose. Okay, so let's start. I'm not just going to show you, teach you this, but we're also going to model it and mathematically solve it in R. Okay. So first of all, let's try to understand what scale efficiency is practically. When the first DEA was introduced by Chance, Cooper, and Rhodes, okay, when the first DEA was introduced by these guys, Rhodes actually didn't stay much in academia. The CRS, the constant returns to scale, they developed the DEA under the assumption of constant returns to scale. Constant returns to scale is suitable only when you're assuming that all the firms are operating at the same optimal scale size. In other words, you are trying to indicate that the scale at which the firms are operating they are operating at an optimum level. Okay. In other words, they are operating at the sufficient level that they are supposed to operate. The size that they are having, their size is good size. But you know that in real market systems, firms have different sizes. In a particular industry, the size of the firms will be different. Some of them will be very large firms. Some of them will be very small firms. What causes that? That is because of imperfect competition. Because there are some industries, competition is not perfect. We have rather monopolistic and oligopolistic markets, OPEC, okay? And such markets, the size will not be optimal. There are some situations where government regulations, for example, in the banking industry, the government will require that the minimum capital requirement should be higher for foreign banks and lower for domestic banks. Okay. So when that is the case, it means that the size, the scale is not optimal. There are some situations where firms are not able to get finances, but other firms are able to get finances. Okay. Some firms can innovate, and through the innovation, they will be operating at a different scale size than other firms. There could be mergers and acquisitions, okay, conglomerations, and all of these can affect the rate at which firms operate. They will not be operating at the same optimal scale size. And so the CRS assumption is not all that correct in real market systems. So we need another one. Banker et al. In the management science, okay, Banker, Cooper, and Rose came together and then developed a paper, okay, which now has to do with the variable returns to scale, which means that they are taking all the factors we spoke about into consideration. And variable returns to scale is where firms differ in sizes. Now, previously, what has been happening is that most DEA researchers, they will just assume that, oh, this industry is a service organization. And so most service organizations are therefore having different sizes. And so the researcher will select variable returns to scales. And then if the industry is more of a manufacturing industry, then the temptation or robotic industry, because everything is machines, then they operate under the constant returns to scale. But then until you test, okay, until 2002, when Simmer and Wilson developed a test that can help us to be able to test the global returns to scale technology. That is the returns to scale underlying the industry. Until you do that test, statistically speaking, you cannot really make an assumption. that, oh, this industry, this banking industry, this oil and gas industry, this energy industry is operating under constant returns or variable returns. You got to do this statistical test. But before we do that, let's understand scale efficiency. Okay, because it's this same principle that we use to understand scale efficiency. Now, watch what I said earlier, the determination of whether the industry is operating under constant or variable returns to scale. This is known as global returns to scale analysis. Global. But once you've identified the global returns to scale, you can now determine the local returns to scale. The local returns to scale. Now, before we talk about that, let's try to establish the relationship between returns to scale and economies of scale. Okay, when you look at Besanko and Brettigan, you'll notice that returns to scale looks at the connection between the input and the output in the long run. That's a returns to scale. Okay, the inputs and the output. Between the input and the output. Economies of scale looks at the falling part of the long run average cost curve. Okay, so how the long run average cost responds to changes in the input. So as you are using the input to changes in the output, as you are using the inputs to produce the output, as the outputs are being produced, how is that leading to a reduction in the long run average cost curve? And that is where economies of scale comes in. Economies of scale is when the long run average cost curve is falling. It's a falling part, the reducing part of the. So when you produce more because of large size, and when you spread the cost over the large production, that is the economies of scale. And so if we have economies of scale, then you can have what? Diseconomies of scale. And if it is not economies of scale and diseconomies of scale, in between them is the constant returns to scale. Okay, constant returns to scale. So when we talk about the local returns to scale, in the DEA literature, there is a way you achieve it. You are still using the industry, but after using the industry connections, when I say industry, I'm talking about a constant returns to scale, the variable returns to scale, and now the non-increasing returns to scale. Of course, we also have the non-decreasing returns to scale, but we don't need that one. All we need is just these three to be able to determine the local returns to scale of a firm. So in this case, not the industry, but for a particular firm, what is the location of that firm in the technology set? Okay, not the technology. So you can have a situation where the entire technology is exhibiting constant returns to scale. Okay, but then some of the firms are not exhibiting constant returns, but they are exhibiting decreasing returns or increasing returns. Okay. So this is at the individual firm specific level. And that is where I want you to understand. Exactly, David. So the local returns to scale is firm specific. The global returns to scale is what? You can tell us now. Okay, you can raise your hand or you can type it. The global returns to scale is what? It's not firm specific, but what? The global one. It is industry specific. It's the industry, exactly. It's an industry specific. Okay, so once you get that part, now, but before you can do that in the individual local returns to scale, you have to first of all understand the industry one. So how do you do that? Well, the general model of the DEA model, when you do that DEA model, okay, without adding this constraint, what is a constraint? The constraint is that the weighted sum of the lambdas, the lambda j you see here, is equal to 1. Without adding this weighted sum of the lambdas equal to 1, without bringing that constraint, you have constant returns to scale. So whenever you have constant returns to scale, you do not, okay, let me just Highlight this thing because this is important. Whenever you have constant retention scale, okay, you do not bring the variable retention scale assumption. Okay, that's what is known as a convexity assumption. You don't bring this convexity assumption, okay, which is the sum of lambda equal to 1. But the moment you bring the sum of lambda equal to 1, you are creating the frontier. You are creating is not a straight line, you know, a CRS frontier, but it is a piecewise curved, you know, VRS frontier. Sometimes you don't even want the VRS frontier. You can test, and you will note that the industry you are dealing with is non-increasing returns. Now, what is that non-increasing returns to scale? And again, you're going to see these graphs very soon. Non-increasing returns to scale is when you are scaling both the input and output downwards. And I'll come to that. When you are scaling the input and output downwards. But when you are scaling the input and output upwards, that is the non-decreasing returns to scale. Okay. But the non-increasing returns to scale, this is the constraint you have to add to the DEA model. So when you add this constraint to the DEA model, remember it is less than or equal to, then we are talking about what? Non-increasing returns to scale. However, when the sign is greater than or equal to, then you are dealing with non-decreasing returns to scale. All right. So like I said, we'll check all of these things. We'll check all of this. Let's go back to the local returns scale. So let's assume that you have estimated the DEA model under constant returns scale, and then you have your efficiency scores. Okay, what efficiency scores did you get? Well, you've estimated the model and you got this efficiency score, which is known as constant returns to scale efficiency score. That's all you have. You have this efficiency scores. Now you go and estimate the model again under VRS, the same model, and then you get the VRS technical efficiency score. If your constant returns to scale technical efficiency score equals that of the VRS technical efficiency, if you have this constant returns to scale score equals the VRS score, then we say that that DMU, and this is for a particular DMU, okay? That DMU is scale efficient. Now, in this case, when you estimate the scale efficiency score, remember that the scale efficiency score for any particular firm is the technical efficiency of that firm under the CRS divided by the technical efficiency of that firm under the VRS. Okay, so take note. So when the TE for the CRS equals the TE for the VRS, then the scale efficiency is 1. Okay. That is when the scale efficiency equals to 1. And in this case, we say that firm is scale efficient. Now, if a firm is scale efficient, it also means that that firm is exhibiting constant returns to scale. Constant returns to scale. Okay. Now, so you've estimated a kind of 2 DEA models here. Okay. The first one is under the CRS, the second one is under the VRS. But if it is not constant returns to scale, then it means that it might be variable returns to scale. But you see, what you want to know is whether that firm is operating at the local level. And the local level is constant returns, increasing returns, or decreasing returns. Okay, that's what you want, decreasing returns. It's either one of them. Now, we've already established that the TE score is not the same as the TE CRS is not the same as the VE VRS. TE VRS is not the same. Okay. And so what do you do? If it is not the same, you go to the next step. So the next thing to do is to go ahead and estimate that same industry score, this time introducing the non-increasing returns to scale. And then you use that to estimate the score. And then when you go and check this DMU, okay, this DMU that you are dealing with, if you go and check the score for it, you will then notice that, now it has something different. And what could that be? Well, the first thing is that you will notice that if that technical efficiency under the NIRS equals the VRS, because remember, we've taken the CRS one out. Okay. Then if that is the case, if the NIRS equals the VRS score, then that DMU, listen carefully, this is interesting, that DMU is scale inefficient. Now, if the firm is scale inefficient, what it means is that the scale efficiency score is less than 1. Okay. So the scale efficiency score is what? Less than 1. But if it is scale inefficient, you have to be specific and tell me where it is operating. And that means that the firm is operating at an increasing returns scale. So in the technology set, the specific local location, the location of the firm is increasing return. I'm going to show you a graph of that. You find this interesting. So that is when you can use these two scores and when they are equal. But what if they are not equal? Okay, what if they are not equal there? If they are not equal, it means that that firm is still scale inefficient. Okay, but the score is greater than 1. Okay, and I'm saying that greater than 1 because in the package we shall use max DER, this time not a benchmarking, but a DER, you will notice that the scale efficiency, when it is greater than 1, it means that that firm is exhibiting decreasing returns to scale. And this is what we say determining the returns to scale at the firm level, determining the scale. So you're going to see that some of them are going to be constant returns to scale. Some of them are going to be increasing returns to scale. Some of them are going to be decreasing returns to scale. But what do these mean? It's not just telling me that they are increasing returns to scale, constant returns to scale. What does that mean? What it means is that if firms are increasing returns to scale, then it means that they can merge with firms that are decreasing returns to scale. It means that one of them is too big and one of them is too small. So the too big and the too small can come together and then they will form a merger. So many mergers and acquisition are as a result of this increasing and decreasing returns to scale. Before we go into the nitty-gritties and get a practical interpretation of this, let's try to get a bit of a graphical sense. Okay. So I've told you that apart from the constant returns and the variable returns for the technology, you can have non-increasing returns and non-decreasing returns. These are the two graphs. Now watch something very carefully, and I'm going to draw something that you probably know. Okay. Now, if you look at this graph, if we start from the origin and we go straight like that, what curve am I drawing here? What am I drawing here? You can tell me. If I draw that thing straight, okay, what am I drawing? Fantastic, CRS, good. Okay, that is CRS. Okay, now if I don't do that, and this time after getting here, I move to this level here, and then I move to that level there, okay, before I now add these ones to it, okay, and then have these ones to that, okay. What graph now am I drawing? Yeah, what graph now have I drawn? What graph now have I drawn? That is VRS, fantastic, excellent. That is VRS. Now, watch the non-increasing, okay, non-increasing, they start from the 0 and it keeps kind of rising, and then at some point it will start falling. That's why it's non-increasing. But whichever way you start, at the end of the day, it will look like from D, even from B, diminishing returns are setting. Okay, so and at D, it will start going down. They start having kind of negative marginal returns. So that is why it is non-increasing returns to scale. That's how the graph looks like. Now look at the other one below. The other one below is non-decreasing, because as you look at it, if you look at this edge there, it keeps going and going and going. It's not decreasing. So it's non-decreasing returns to scale. So non-increasing returns to scale graph and non-decreasing returns to scale graph, this is how they look like. And these two help you, okay, to determine that particular. Remember, they are constraints for them. Okay, this one is when you have the less than or equal to. The non-increasing returns is when you have the less than or equal to the lambda, the sum of the lambda being less than or equal to 1. And this is where you have the sum of the lambda being greater than or equal to 1. Okay. So that first one is a non-decreasing, and the second one is a non-decreasing, non-increasing, non-decreasing. Okay. So this will help you to identify the retention scale that apply locally at the frontier. Okay. Now, let's take a particular one. Now let's get excited. And let's take a particular one, a graph. I'm going to show you graphically before we show you mathematically. So we are going to estimate the scale efficiency of a particular graph work. Okay. So look at it. I've already told you that technical efficiency, as we know, is the pure technical efficiency times the scale efficiency. So the technical efficiency is a pure technical than the scale. And so it means that the scale is the technical divided by the pure technical. And when I say pure technical, I'm talking about the technical efficiency estimated under the VR. Take note of this. This is important because you're going to do this at the productivity level. Okay. Now watch this graph. If you look at this graph carefully, from the origin, from the zero, not from zero actually, from this point, okay, let me just go back and show you the point. From this point here, okay, at this point X here, okay, passing through this section, getting to A, keeping going, keeping going, keeping going, okay. Which graph is that? Which graph am I trying to show there? Okay. Which technology graph am I trying to show there? You got to be knowing these things all the time. That's a VRS, thank you. Okay, now listen. There is a particular firm that you see here, and that firm is firm A. There's also another firm, which is firm B. Okay. Please note carefully what I'm about to say. The increasing returns, decreasing returns, constant returns, they are determined along this VRS frontier graph. They are determined along this graph that you're seeing here. Okay, so keep that in mind. But after determining that the scale efficiency is determined when you have both the CRS and the VRS. Because remember, you can't get the scale efficiency unless you know the T technical efficiency CRS and divided by the technical efficiency VRS. Okay. So the scale efficiency, you need both the CRS graph, which is a vertical, the straight one from the origin. But to determine the retention scale, you need the VRS graph. You need the VRS graph. Okay, so let's take this VRS graph. Okay. Where do you think B is? Is it on the increasing returns, constant returns, or the decreasing returns? Because B is on the VRS graph. What do you guess first? And of course, if you tell me, I'll probably ask you to give me your reasons. Where is B on the constant returns, increasing returns, or decreasing returns? This graphical thing is interesting. Okay. Now, well, for your information, you can see that the CRS, the constant returns graph, cuts through B and C, cuts through B and C. So obviously, you should know it is constant returns. That's it. Excellent, Stephen and Mark. It's constant returns. So B is exhibiting constant. What about C? What about C? What about C? Is it increasing returns, decreasing returns, or constant? Please, I need all of you to type in some answers. Okay, that is also constant returns, and that is also correct. Okay, so that is key. Okay, now let's go to the ones that are not on the constant returns. Okay, remember, okay, and I'm giving you a clue. Increasing returns is when that firm is at the portion where the VRS looks like it's rising. Okay, looks like it's turning and rising. Okay, either it's rising at a vertical section or it is rising at a vertical steep section. Okay, and then the decreasing returns is when the VRS graph is at the kind of moving towards the horizontal section. It's turning in the horizontal section a flatter way. And then when it is purely horizontal, those in that location, they are the decreasing returns. Okay, so let me ask you now, because you know I'm going to be asking you. So look at point A. Point A. Okay, if you look at point A, it is on the frontier of the variable returns to scale graph, or we call it the BCC graph, Banker, Chance, and Cooper. So if you look at A, it's on that point. Now, when you look at A is obviously efficient because it's on the efficient section of the graph. Okay? A is efficient. What do you think will be its scale efficiency? Scale efficiency, look at the definition up there. Okay? Look at the definition here. The definition of the scale efficiency is the technical efficiency to the CRS divided by the technical efficiency to the VRS. So what is the technical efficiency to the CRS? The technical efficiency, if you want to measure it, that's why these other lines are giving you, to the CRS. Okay, for point A, remember the definition of efficiency, distance to the frontier divided by distance to the firm. You remember? Distance to the frontier divided by distance to the firm. Okay. So what is the distance to the frontier? In this case, the CRS frontier. Look at the definition of the SE up there. Okay. So the SE is going to be the technical efficiency for the CRS. So what is the distance to the frontier? The distance to the frontier is L to the point of M. Okay. So the point L here to the point M, that is the distance to the CRS frontier. Okay. So that would be LM. Okay. And according to the thing, is divided by distance, divided by the technical efficiency for the VRS. So again, technical efficiency for the VRS would be distance from the origin, which in this case is L, to the frontier, this time to the VRS frontier, which is A. Okay. So distance. So in fact, let me do the first one properly. Okay. So the CE, first of all, let's look at the TE. The TE is distance to the CRS frontier. Okay. So that will be LM divided by distance to the firm. That will be LA. Okay. And then the other one, the TE for the VRS. Okay. This is for the CR. The TE for the VRS is distance to the VRS frontier, which is what? A. So that one will be LA divided by distance to the firm. The firm happens to be at the point A. So distance to the firm will be LA as well. And according to the CE definition, it is the top one. Okay, it is the top one here, which is the constant returns technical efficiency, divided by the down one here. Okay, so you're going to have LM over LA, okay, divided by, but I'm going to do times, which is the same thing, times LA over LA. Okay, so LA will cancel, LA will cancel. You are left with what? LM over LA. What is LM over LA? When you look here, okay, LM is the distance from this one to that divided by LA, which is what? Distance from this section to this section. So the scale efficiency is that gap that you see, that gap between the CRS frontier and the VRS frontier. Now, when you look at this definition, okay, look at it, okay, and you will notice that it's below 1. How do we know that it's below 1? Because the LM, if you look at the LM distance, okay, up to the LA distance, you will see that the LM is shorter than the LA. And because LM is shorter than the LA, the value is expected to be what? Less than 1. All right. So we are now able to say clearly that this value of the scale efficiency of this guy is below what? 1. And if it is below 1, then we are expecting it to be what? We're expecting it to be IRS, because we said that the IRS is when the efficiency is below 1. What do you think will be the local retention scale for R? R, who can tell me for R? Will it be CRS, IRS, or DRS? R, letter R. Letter R. What would it be? What will it be? Letter R. Give me your answers. Give me your answers. Give me your answers. R. Okay. R. What would that be? R for Romeo. Okay. That would be IRS. That would be IRS. Very good. That's a mark. Okay. That would be IRS. What about E? What about E? What about E? Okay. Watch the location. Okay. Watch the location. It's going to be the same thing. I don't want to go deeper. It's going to be the same thing. Okay. It's going to be the same thing because when you look at it, it's going to be the distance to the, so it's going to be the distance to the PQ and distance to the PR. Okay. And that is it. Okay. Now, so you can see those that are constant retention scale, we call them Banker in 1984 paper, which he wrote alone, calls it the most productive scale size. Okay. The most productive scale size. All right. So you should find the E, and I've already given you the answer. Okay. All right. So you will notice that the E is also increasing return. So all the firms located at this section, okay, all the firms that are located at this section are exhibiting what? Increasing returns to scale. And then all the firms located at that section are exhibiting decreasing returns to scale. But to note, this is dependent on the orientation you are using. Okay, this is dependent on the orientation we are using. I'll come back to that point because it's very important. Okay, the orientation can change your answer. If you are using input orientation, that is different if you are using output orientation. Let's look at that slightly. And I've made that point very clear here. Okay, so note that the results secured may depend on the orientation that you are using. Why? IRS, increasing returns to scale, may result from an input-oriented model. So if you are doing input-oriented model, okay, you are going to have more of IRS. Why? Because watch it carefully. If we look at E and we're doing output orientation, and you try to draw this output-oriented graph, okay, suppose we're trying to find the efficiency for E and its output orientation, you go up there and you see the section is going to hit, is going to be the constant returns to scale section. It's not going to hit this variable returns and then this graph for you to find that it is in the lower section. Okay. And in terms of even determining the returns to scale, we said you use the VRS. So if you look at the VRS, input orientation will hit the increasing returns, but output orientation will hit the constant return. So it is orientation dependent. Is orientation dependent. Let me take a particular example, okay? Because that will highlight the thing very well. Let's take a particular example. Look at this graph carefully. Look at it very carefully. Look at the DMUH. Okay, look at the DMUH. Now the VRS graph, we have 5 DMUs here. The DMU-A is at the bottom. The DMU-B is on the constant return, C is on the constant return, and then D is on the decreasing returns. Okay. Look at figure H. Look at H. Look at H. Look at H carefully. When you look at that H, okay, and you will notice that the section OBC, okay, this section BC here, they are all exhibiting constant returns. Okay. And then the VRS frontier is the AB, okay, BC, and then CD. That's the VRS frontier. So you can see these frontiers that we have indicated. Now, which one is exhibiting what? Well, you can see this thing so beautifully here. Oops. So beautifully here. you will notice that B and C are exhibiting CRS, but when you look on line AB, IRS is prevailing to the left of B. Okay, so that's the section there. And then when you look at CD, DRS is prevailing to the section. But let's look more at H, because that for me is important. Okay. Even though the explanation is, I'm just going to go very, very quick here. If you are trying to look for the local returns to scale for H, okay, and you are doing input orientation, it will hit the frontier on this section. Okay. It will hit the frontier on this section. And when it does that, H will be identified as operating at an increasing return because you are dealing with input orientation. But if you are dealing with an output orientation, it will go up there and then it's going to hit the output oriented graph. Okay, go up there. It's going to hit the output oriented graph at this section, which is exhibiting what? Decreasing returns. So the orientation will determine where H in this particular sense is going to be. Okay. So the orientation can tell clearly the return. But sometimes you don't need orientation, like B like this, you can see clearly that it's exhibiting constant returns and then the rest. Okay, so that is what the point we say, that if we estimate the VRS local returns for H, using input orientation, it will exhibit IRS at H prime. Okay, and you can see that it is exhibiting IRS at H prime. But when you look at the output orientation, it will exhibit DRS at H prime prime. Okay, and that is this section there. All right. Of course, most of the things can be found in the ZOO 2009. So why are we talking about local returns to scale? And these are some of the things you need to use to justify before doing returns to scale at the firm level. Okay. First, note that if CRS holds at any Pareto efficient point, then if you should raise the input, if CRS is, IRS, if IRS, increasing returns, is holding, what it means is that if you should increase the input by a small percentage, the output is going to rise by a bigger percentage, all things being equal, because there's an increasing. So if you increase the input by small, the output is going to increase by large because of the increasing returns that is holding. But if it is decreasing returns that is holding, it means that if you increase the input by a small percent, a large percentage, the output is still going to rise by a small percentage. Okay. So if you determine the local returns at a DMU, that is very important because managers can make decisions related to measures. Why? Because a DMU, which is operating at an increasing returns, it has to increase its too small size. Okay. If it can control that, if it can control that, it has to increase the too small size. The size is so small because that little increase, that little extra increase will be much more compensated by, a higher rise in output. So you don't need to increase the input by large. You just need to increase the input by small, and the output is going to rise by big because you are aware that the firm is operating at an increasing return. Okay. And when the firm is already at a constant returns to scale, optimal scale size, okay, banker now calls that point the most productive scale size. That means the firm is at the most productive. Such firms, you don't need to merge them with any other. So you got to know the local returns to scale because else, you got to know because then you can make managerial policies even better. Okay, so what I'm going to do now is that I'm going to show you how to estimate the returns to scale in R. Okay, I'll come back and then I'll come and show you that one. All right.